There is a version of this question that lives rent-free in the back of a certain kind of brain. You have seen the footage, the trainer stepping into the enclosure, the animal locking eyes, the moment of absolute stillness when it is genuinely unclear who is in charge. And somewhere in the part of your mind that has never fully accepted that you are a soft, slow, largely defenseless primate, a thought forms. Could you do that with a velociraptor? Not a lion, not a killer whale, the velociraptor. The answer involves sickle claws, Soviet foxes, a very specific part of the human femoral artery, and at least one man in Florida who made a catastrophically optimistic life choice. So, could we tame a velociraptor? Let us find out. Taming is behavioral modification of a single individual. Domestication is genetic restructuring of an entire species across hundreds of generations. They are not the same thing. You can tame a lion. Siegfried and Roy did exactly that. For 30 years, they raised white tigers from cubs, and they logged thousands of hours of conditioning. In 2003, one of those tigers put Roy Horn in the ICU. The tiger was not reverting to the wild. It had never left. It was always a tiger. And on that night, tiger logic took over. The most instructive experiment on this question involved foxes. In 1959, Soviet geneticist Dmitry Belyaev began selectively breeding silver foxes, choosing only individuals who showed reduced fear toward humans. After 40 generations, roughly 40 years, they began approaching humans voluntarily, wagging their tails and seeking eye contact. 40 generations. For a mammal with mammalian brain chemistry and a nervous system that shares enormous evolutionary heritage with ours. A velociraptor's most recent common ancestor with us lived 320 million years ago. Its entire emotional architecture was built for completely different priorities. That is where this conversation starts. Velociraptors were not scaly reptiles with attitude problems. They were feathered, hollow-boned, warm-blooded, and they sit within the same group that produced modern birds. A velociraptor is more closely related to a pigeon than to a crocodile. That is not a metaphor. That is phylogenetics. So the right comparison is not a dog trainer, it is a falconer. Humans have practiced falconry for 3,500 years. The consensus is unanimous. You do not tame a hawk. You negotiate with one. The bird is conditioned to associate the handler with food. It does not view the falconer as a companion, it views the falconer as a vending machine. The moment the vending machine stops producing, the relationship is over. The Harris hawk is the gold standard, the most trainable bird of prey alive, often called the dog of the hawk world. It weighs 1 to 2 pounds, and it takes 6 to 12 months of daily work to reach basic reliability. Never, in 3,500 years, has one been described as a pet. Now apply that to an animal that weighs 30 pounds, has functional grasping hands in addition to taloned feet, and is currently deciding whether you are food or a problem. The falconry model fails almost immediately for one reason: metabolism. Velociraptors were warm-blooded, with metabolic rates roughly 20 to 30 times higher than an equivalently sized reptile. A monitor lizard the size of a raptor can go weeks without eating and stay stable. A bird that size, missing a single day without food, shows measurable behavioral changes. For a Harris hawk, the effective training window can be as narrow as 20 to 30 grams. That is the weight of 5 paper clips, and it separates cooperative from unmanageable. The raptor's aggression, its hunting drive, and its constant environmental scanning were not personality traits. They were metabolic necessities. The calm moments were the brief intervals between the natural states. Training has to happen in those intervals. The counter-argument. Velociraptors were smart. True. Velociraptor's encephalization quotient was approximately 5.8, the range of modern crows and parrots. Crows use tools, recognize individual human faces, and pass information about dangerous humans to their offspring. A crow will remember that you were unpleasant to it in 2019 and tell its children. What a crow will not do is obey you. Intelligence and trainability are not the same thing. In raptor brain endocasts, the dominant structures are the olfactory bulbs and optic lobes, hunting tools. The regions associated with social bonding and obedience, the regions that make dogs trainable, are minimal. A dog follows a human's pointed finger to find a hidden object. A chimpanzee, considerably more intelligent, cannot reliably do this. That ability is not intelligence, it is 15,000 years of evolutionary pressure toward human comprehension. The raptor faced none of that. A crow solves a puzzle box in 30 seconds. It also steals your car keys and shows no remorse. Same tradition. One approach sidesteps most of these problems: imprinting. If a human is the first thing a hatchling velociraptor encounters, it will bond to that human as its primary social referent. Konrad Lorenz demonstrated this with greylag geese in 1935, and the goslings followed him for life. The problem is what imprinting does to predators. In bird of prey rehabilitation, imprinted raptors are among the most dangerous animals to handle because they have lost their fear of humans while retaining all predatory instincts. An imprinted hawk sees its handler not as a superior, but as a peer that it needs to establish dominance over, using every tool available. An imprinted velociraptor might seek the handler's presence, but it would also negotiate dominance using its full toolkit. Which brings us to the toolkit. Set aside every psychological problem. Imagine a velociraptor that is 95% reliable. What does the other 5% look like? The sickle claw was approximately 6.5 centimeters long, designed for penetration and gripping, not slashing, driving in and staying in. The femoral artery runs along the inner thigh. Penetration of 2 to 3 centimeters produces fatal blood loss within 3 to 5 minutes. The raptor's sickle claw is twice that threshold. Every safety system in large animal management is built around one principle: neutralize the primary weapon. Muzzles for dogs, bits for horses, distance tools for big cats. All of it assumes the primary weapon is the mouth. A raptor's primary weapons are on its feet. The feet cannot be muzzled. Always active, always independent, always in range. The margin for error with a raptor is exactly 0. Not small. 0. Then there is the scheduling problem. Velociraptor is believed to have been cathemeral, active in irregular bursts during day and night, based on scleral ring analysis suggesting a low-light specialist. A raptor at 3 a.m. is at full metabolic speed, full sensory sensitivity, full prey drive. Its handler is sleep-deprived with measurably slower reaction times. Average human reaction time to a visual stimulus is 250 milliseconds, rested, alert, and expecting it. A velociraptor closing from standing does not leave that window. The animal is most dangerous at precisely the moment the handler is least capable. That gap is biological. It cannot be trained away. And there is the question of whether the conversation could happen at all. Dogs read human expressions with a specificity unique in the animal kingdom, follow pointed fingers, and track eye movement. 15,000 years of coevolution produced a communication interface that works from both sides. Cassowaries produce infrasonic threat displays below 20 Hz, beneath human hearing entirely. Full behavioral information, in a format we simply cannot access. A raptor's warning signal may have worked the same way, preceding a strike by fractions of a second. In animal training, a conversation you cannot follow is not a conversation, it is an ambush with extra steps. Here is the final conclusion. Assume every problem has been solved, a raptor that functions in controlled conditions with something approaching predictability. What has actually been created, domesticating wolves into dogs, required removing the traits that made wolves wolves. 15,000 years of pressure replaced fearlessness, predatory independence, and rigid social structure with their opposites. The result is extraordinary, loyal, communicative, genuinely bonded. It is also an animal that would not survive 72 hours in the environment its ancestor dominated. A safe raptor would have a suppressed prey drive, reduced aggression, diminished predatory instincts. It would have the shape and the feathers. But everything that made it a raptor would be gone. the metabolic urgency, the sensory precision, the explosive intelligence of an animal built for a world where being second was not survivable. You would not have tamed a raptor. You would have disassembled one and left the housing. Every system in Velociraptor, from the metabolism in the brain to the sickle claw, the communication, and the sleep patterns, follows the same design philosophy at every layer. Pull any thread, and the whole thing changes. To tame it, you would have to strip away everything that makes it untamable, and everything that makes it untamable is the same thing that makes it a raptor. So, could we tame a Velociraptor? You could attempt it. Years of work, specialized infrastructure, a medical team on standby. You could possibly achieve something that looked, from a distance on a good day, like a working relationship. What you could not do is make it safe. What you could not do is make it yours. And what you could not do is make it anything other than what it always was, a 30-pound, feathered, perpetually hungry machine that the Cretaceous spent millions of years perfecting, and that evolution equipped with absolutely no interest in your feelings about it. 66 million years of distance between us and that animal was not a tragedy, it was a gift.